this one's a little bit different. We see this symbol here. This symbol means parallel. So if you didn't remember that, we have parallel here. Some things to keep in mind when we're talking about parallel lines. In chapter 3, we talked about parallel lines, and this line that cuts it is called a transversal. Okay, so if these are parallel, this is my transversal. There were certain angles that were the same size. Okay, we had angles like these that were in the same position. Those were called our corresponding angles. Those were the same size. Okay. Then we had angles that were inside but on opposite sides. Oops, I'm going to put 2 arcs there. Those were called our alternate interior angles. Okay. And then we had alternate exteriors also. So an example of those would be like this one and this one. Those were our angle pairs that were the same size. Okay, so those are important things to remember. Anytime we see these parallel lines, we might have to look for one of these. Okay, so first, it's saying PQ is parallel to RS. So when I start my proof, I know I'm going to put my givens down. So PQ is parallel to RS. Now, looking at my picture, this is PQ, this is RS. I'm going to turn my paper around, and this is going to be my transversal that I'm dealing with. Okay. If I focus on the pink lines, I can see that this angle and this angle are alternate interior angles. So those angles are the same. PQS is the same as RSQ. That's what I'm going to add to my proof next. So this was given, and now I'm going to say PQS is congruent to RSQ. And those were alternate interior angles. Okay, my next given, I'm going to do this one in a different color, is QR is parallel to PS. So now I'm going to look at QR going this way and PS going this way. Okay, I'm going to use my same transversal, but now my alternate interiors are here and here. Okay, because I had to turn my paper. So those angles are the same. How do I name those angles? This was given. This angle, Q has to be in the middle, so RQS. And over here, S has to be in the middle, so PSQ. And that's alternate interior angles. Okay. We know what goes last. We know this statement has to go last. So now I've just got a few blanks left to fill in. Okay, so I have to look at my picture and decide if I have any sides that are shared or any angles that are vertical. Those are things I'm looking for. This side going down the middle is in both triangles. So this side needs to be put into my proof. That side is QS. When a side is shared and congruent to itself, that is called reflexive. Okay. So when I look at one triangle at a time, just this one, I see angle, side, angle. The side is included. It's between the angles. When I look at this triangle, I see angle, side, angle. So that's going to be my congruency shortcut. Okay, angle, side, angle, congruency. Next, we've got C is the midpoint of AD. So we add that here. Oops, I spelled midpoint wrong. Oh well. C is the midpoint of AD. That's given. So what does that mean? If C is in the middle, it means these are the same. So that's what I add next. Because that's what midpoint means. It's a definition of a midpoint. Okay, next, AB is parallel to CE. So AB here is parallel to CE here. So we're going to add that. So now I have to decide, what am I looking for? Well, I see this line cuts into both of them, and I see this line cuts into both of them. If I looked at this line first, my alternate interiors would be here with something like this, but that's not in the triangle because it's split up. So I don't want that. If I look at this line as my transversal and kind of turn my paper, I can see that this angle and this angle correspond. They're in the same position. They're both under the parallel line and to the right of the transversal. Under the parallel line to the right of the transversal. So this angle matches. That's what I'm going to put next. So angle BAC is congruent to angle ECD. And those were corresponding angles. All right, next, BC is parallel to ED. So BC is parallel to ED. This is given. So this one and this one are the same. If I try to look at the same transversal, so using this as my transversal again, I can see that this angle here and this angle here are in the same spot. This angle's above the line and to the right of the transversal. This is above and to the right. So this angle matches up. That's the next thing I'm going to add. So angle, if I want to name this one first, ACB is congruent to CDE. Okay, and we know what has to come last. We know our proof has to come last. So now I just have to pick out my reason. And my reason, this is a side here. If I look at each triangle, I have angle, side, angle, angle, side, angle. ASA congruent.